where you're talking about individual questions and objective type and either get it right or get it wrong. If for any reason it is quadratic, then use the mean. Now, there are various kinds of numbers, and I'm going to talk through one type of classification of numbers and talk about what are all the measures of centrality that apply to these numbers. So there are things that are not really numbers. So you have, let's say, distance. Districts are not numbers. You may have a district code of 1, 2, 3, 4, 5, but let's not make the mistake of treating those as numbers, because a district code of 2 is neither twice as large as a district code of 1, nor is it one more than the district code of 1, nor anything else. You absolutely cannot compare that. And then there are what are called natural numbers. Now, natural numbers are 1, 2, 3, and so on. Now, let me loosely map some kinds of data that you might get to natural numbers. If you had survey results, so somebody might say, I've got, I rate this as bad, somebody says I rate this as average, somebody says I rate this as good. Now, you might translate that to let's say 1, 2, and 3. Now, here your intention is not to say that average is twice as good as bad and good is twice as good as average. You're not treating these as comparable in any way. You're just saying that this is the first, this is the second, this is the third. Actually, more properly, these are called ordinal numbers, in the sense that they can be ordered. So you can put numbers in an order and nothing more than that. Then there are numbers that you can properly treat as integers. So you can say that this number is x more than y. So let's say I have to go from here to Shimoga and from Shimoga to Pune. I can treat these distances as, so the distance from Shimoga to Pune, I can say is more than the distance from Bangalore to Shimoga. But I can also say how much more it is by. I can subtract these numbers. Subtraction has a meaning. And you can do that with you can subtract integers. Now, earlier when I said, talked about natural numbers, now while in theory you can subtract natural numbers, you can't always subtract natural numbers. For example, if you said, what is 2 minus 3, where 2 is an integer and 3 is an integer, you say minus 1 because minus 1 is an integer. If you said, what is 2 minus 3, when 2 is a natural number and 3 is a natural number, you say, I can't solve this problem because there is no such natural number as minus 1, which is what folks before, I don't know if you know that popularly, but let's say sometime BC, that's by and large what people would say. I can't take away 3 apples from 2 apples. You've got only 2 apples. I can at best take away 2 apples from them, which leaves me nothing, but that's nothing either. So I can probably at best take away only 1. Right? So you can subtract integers, you can't really subtract natural numbers and expect to get a meaningful number, but you can always do that with integers. You can't, however, divide integers and expect to get a meaningful number. 4 divided by 2, yeah, that's an integer. 4 divided by 3, that's not an integer. So somebody says, okay, I've got 4 apples divided among 3 people. I can't divide among 3 people, just slice it. But then you say, yeah, but that's just an extra slice. If I chop off an apple and I get 2 halves, that's 2 half apples. That's not half an apple because there's no such thing as a half, and that's just 2 whole half apples. So integers are dealing with whole quantities, and then we need to move on to the domain of rational numbers, which says that there is such a thing as 4 divided by 3, and it's a logical concept in itself, and I can start doing things with it. I can multiply it by 6 and get back 8. So I can perform operations like multiplication and division on any rational number, and it will always give me some rational number. So that's another layer of the hierarchy. Now this you would think would have solved most problems, but it doesn't. Turns out that there are numbers that can never be expressed as the ratio of 2 numbers. You ask the question, what number when multiplied by itself gives me 2? You say 1.5 times 1.5 is a little more than 2. 1.25 times 1.25 is a little less than 2. So it's somewhere between 1.5 and 1.25. You try and find a number between there. You keep going deeper and deeper and deeper and deeper and deeper, and you find that you will never ever find a number that you can write down in its entirety that will give you the answer 2. That's what an irrational number is. There is a rumor that Pythagoras was in fact killed for creating the concept, expounding the concept of irrational numbers. A lot of mathematicians, in fact, have been killed for saying stuff like this. Cantor was killed for talking about the mathematics of infinities.
He wasn't killed.
Was it? I think
He went to the madhouse.
okay.